What's up mga ka-Einstein? Sir Janus nga pala, ang inyong magiging gabay tungkol sa pagkatuto sa Grade 10 Science, Unit 1, Earth and Space. Ngayong araw, ating pagtutuunan ng pansin ang tungkol sa plate tectonics. So handa na ba kayo? Kung bago ka pa lang sa channel ko, huwag kalimutang i-click ang like button, subscribe para updated ka sa mga bagong learnings. So let's get right to it. Let us review yung mga past concepts that you could use for your learning sa plate tectonics. Sa grade 6, nandyan yung tatlong module. Nandyan yung earthquake, volcanic eruptions, weather patterns, motions of the earth, at saka yung solar system. Sa grade 7 naman, nandyan yung Philippine environment, interactions, saka yung seasons and eclipses. Sa grade 8, nandyan yung earthquakes, faults, understanding of typhoons, and other members of the solar system. Grade 9, volcanoes, climate, constellations. Sa grade 10, dalawa lang yung focus, plate tectonics at saka yung Earth's interior. So ito nga pala yung specific concepts na natutunan mo from grade 7 to 10, which would be instrumental to fully understand yung topic natin sa grade 10, which is plate tectonics. If we are going to look at it closely, dalawa lang yung main focus ng first quarter. Yung Module 1, yung plate tectonics, at saka yung Module 2, Earth's interior. So lahat ng mga modules ay magre-revolve sa dalawang main topic na to for the first quarter. So here's a closer look. Kung gagamitin natin yung learner's module, it comprises of 6 activities. So lahat ng to ay sobrang enjoy. So you might want to try this out. So binubuo siya ng 6 activities. Activity 1, find the center. Activity 2, let's mark the boundaries. Activity 3, head-on collision. 4, going separate ways. 5, slide and shake. Drop it like a sandpot sa activity 6 at saka find the center sa activity 7. Ito naman yung mga activities na bumubuo para sa Earth's interior. So, andyan yung amazing waves, dynamic Earth, let's fit it, andyan din yung drifted supercontinent, split and separate, at saka yung how fast does it go, at saka yung push me up and aside. So, ano nga ba yung tinatawag na plate tectonics? Meron ka bang idea? So, yung plate tectonics ay isang teorya na nagpapaliwanag na ang mundo ay binubuo ng malalaking tipak ng lupa. Ang malalaking tipak ng lupa na to ay tinatawag na lithospheric plates. Itong mga lithospheric plates ngayon ay nasa taas ng mantle at nakadepende sa paggalaw kung ano yung magiging resulta or epekto nito sa mundo. Sa pag-aaral ng plate tectonics, merong dalawang principle na dapat lagi mong tandaan para may paliwanag kung bakit gumagalaw yung mga lithospheric plates. Principle 1, ito ay dahil sa cooling of the earth, at saka yung principle 2, it is because of gravity. Pwede natin itong maihambing sa sinaing or yung isang boiling pot or sopas. So ano ba yung napapansin mo sa sinaing? 'Di ba? Napapansin mo na habang tumataas yung temperatura, ang tubig ay kumukulo. So i-compare natin. So yung magma, pag masyado nang mainit, it would rise up or to. Once it reaches the top, it would cool off or lalamig siya, and then it would be pushed back down. So ayan, and then when it reaches again a certain temperature, tataas na naman uli siya. So mapapansin mo na ito ay cycle. Yung cycle na to ay tinatawag na convection current. Together with gravity, yung convection current are the reasons kung bakit gumagalaw yung mga lithospheric plates. Ano-ano nga ba yung bumubuo sa lithospheric plates? So actually, merong 8 primary plates, yung iba naman ay binubuo ng mga secondary plates, meaning mas maliliit sila. So yung mga primary plates includes Eurasia plate, Juan de Fuca, Philippine, Australian, Pacific, Nazca, South American, you have also Cocos plate, Antarctic plate, at yung iba pa. So yung ibang mga plates ay merong mga continents sa taas niya, yung iba naman ay wala, meaning nasa ilalim sila ng ocean. Pero lahat ng to, mapa-primary man or secondary, lahat ng mga plates na to ay gumagalaw. And that is because, from what we learned earlier, because of convection current. Quick question mga ka-Einstein. Do you have any idea as to how they come up with this design of the plate boundaries? How did they identify that there are 8 primary boundaries or there are 8 primary plates? Gumamit ba sila ng several instruments? Nag-explore ba sila sa iba't ibang sulok ng mundo? What was the basis for the design of the tectonic plates? Yung first basis for the boundaries of the tectonic plates is what you call a seismicity at saka yung distribution of earthquakes. In other words, ito yung mga lugar kung saan nagkaroon ng lindol. So yung mga spots na yan yung mga lugar sa mundo na nagkaranas na ng lindol at patuloy na nakakaranas ng lindol. Another quick question, saan sa palagay mo nangyayari yung mga deepest earthquakes based on the diagram? Okay, so you still have 15 seconds left. Remember yung deep earthquakes po ha, mga ka-Einstein. So kung mapapansin mo, kung pagbabasehan natin yung diagram, mas marami yung earthquakes dun sa mga plate boundaries or kung saan nagtatagpo yung mga lithospheric plates. At yung mga pinakamalalim naman ay nangyayari dun sa mga subduction zones. Another quick question, saan most likely makakakita ka ng volcanoes? Within the continents ba? Andun ba sa ilalim ng dagat? Between the plate boundaries? Or kung saan nagtatagpo yung dalawang mga plates? So you still have 10, 9, 8, 7, 6, 5, 4, 3, 2, and ayan. So kung titingnan natin sa mapa, where there are earthquakes, there are also volcanoes. And most likely, makakakita ka ng volcanoes on the plate boundaries or kung saan nagtatagpo yung dalawang lithospheric plates. So, ito yung pinagbasehan in order for the scientists to determine what are the different type of lithospheric plates. So, you have seismicity or kung saan nangyayari yung lindol. Another is yung location of volcanoes. And the last one are the location of major mountain belts. So, So you might be wondering, kung gumagalaw yung lupa, bakit hindi ko to napapansin? So actually, gumagalaw siya but it moves very slow. So 1 to 10 centimeters lang per year. So about kung gaano kabilis tumutubo yung mga kuko mo. It isn't much, but if you are going to multiply it by say a millions of years, then definitely yung distansya or yung movement would be very evident or kapansin-kapansin. So yung slowest ay nasa African plate at saka yung fastest naman is nasa Samoa, yung sa Tonga microplate. Let's learn more about tectonic plates. Tectonic plates, like what we said, is also known as the lithospheric plates. Now, let us put this straight. Yung crust at saka yung lithospheric plates are magkaiba. When we talk about lithospheric plates, kabilang na dito yung crust at saka yung upper mantle. When we talk about the crust, it is the outer rock layer of the earth, chemically distinct from the underlying mantle layer. So, yung crust is only a part of the lithospheric plates. When we talk about lithospheric plates, it is rigid and brittle, contains crust and upper mantle, 100 km thick, at meron siya mga fractures na kung saan dito nag-originate yung earthquake. Now let's proceed to another misconception that pertains to asthenosphere. When we talk about asthenosphere, ito yung hotter upper mantle below the lithospheric plates. So yung asthenosphere, mali siyang tawaging ito ay liquid. Actually, it is viscoelastic solid. Okay? So meaning, hindi siya kapareho ng liquid na mabilis mag-flow. Kapareho siya ng plastic na natunaw. So mabagal lang yung kanyang paggalaw. Now let's proceed to the different type of plate boundaries. Actually, there are 3 types of plate boundaries. Yung una ay yung tinatawag na divergent boundary, yung ikalawa naman is convergent boundary, and the third type is the transform boundary. Now, nakadepende sa paggalaw in between these lithospheric plates kung ano yung magiging epekto nito sa Earth's crust. Kung kailan ba magkakaroon ng lindol, ng tsunami, pagbuo ng volcanoes, or pagbuo ng mga mountains. Now, let us try to differentiate between the 3 at kung ano yung mangyayari sa mga lugar na merong ganitong klase ng boundaries. The first type is the divergent boundary. Places with this type of boundaries as earthquakes na mababaw lang at saka mahina. Now, ito yung mga lugar kung saan nabubuo or gumagawa ng mga panibagong lupa or panibagong crust as it pulls apart. Divergent boundaries ay ang paghihiwalay ng mga lithospheric plates. Next type of plate boundary ay tinatawag na convergent boundaries. Now, merong 3 klase. Ang una is yung ocean to ocean convergence. Ikalawa naman yung ocean at saka yung continental plate convergence. At yung ikatlo naman yung continental to continental convergence. The next type of boundary is what you call as convergent boundaries. Now, there are 3 main types for this type of boundaries. Andyan yung oceanic to oceanic plate convergence. Another is yung pagbabanggaan ng oceanic at saka yung continental plates. Another is yung continental at saka yung continental plates. There are 2 main concepts na dapat yung tandaan dito mga ka-Einstein. Yung mas mabigat o yung denser plate, siya yung bababa or papailalim, at saka yung letter B naman, kung halimbawa 2 continental plates yung magbabanggaan, walang magsasabdak kasi pareho silang dense, yung mabubuo dyan are mountains dun sa tinatawag na collision zones. Now let us take a closer look. Titingnan natin ano ba yung mga geologic events na pwedeng mangyari with this type of events. Now, oceanic to oceanic plate convergence, so it could form volcanic island arcs. Andyan din pwedeng mangyari yung tsunami at saka yung tinatawag na ocean trench or yung mga malalalim na parte ng dagat. It is because merong part dyan na pumapailalim, usually yung pinaka-denser na crust. So this is one of the boundary na delikado because this is where The strong earthquakes or yung malalakas na earth lindol ay nag-originate. Aside from that, ito rin yung reason kung bakit merong tsunami because of convergent boundaries. Pareho din yung pwedeng mangyari between ocean to continental plate, but instead, volcanic island arc yung nabubuo. Now let's proceed to another type of boundary, yung sa convergent boundary, and that is between two continental plates. Now here, sa dalawang continental plates, wala nang nangyayaring subduction zone kasi pareho silang dense. Yung mangyayari dito, yung mabubuo yung tinatawag na collision zone or kung saan nagbabanggaan yung dalawang plates. As a result, instead na bumaba, ito ay tumataas and it would form now a mountain. So this is how Mount Everest was formed. Yung last type ng boundary is what you call as transform. In this type of boundary, walang nabubuong panibagong crust or walang nasisirang crust kasi nagsaslide lang siya past each other. But definitely, it would surely cause earthquakes. One clear example of this one is yung San Andreas Fault in California in United States of America. So here are the different sources na pwede kayong mag-research or pwede kayong mag-download in order for you to fully understand about plate tectonics. So kung bago ka pa lang sa channel ko, please do not forget to click like and subscribe and share it to your classmates so that others would also learn. So till next time, Einsteinatics. Thank you for watching.